In Chapter 9, we're looking at Fermat's little theorem. And what Fermat's little theorem states here is that when you have a prime number and you have another number with this property that a is not going to be congruent to 0 mod p, basically a is not going to be divisible by p, then what you're going to be able to say is that a to the prime number minus 1 is going to be congruent to 1 mod p. And so on page 67, there's an example of that. What we have is 2 to the 6th is congruent to 1 mod 7. And so what you can see is that 2 to the 6th is 7 minus 1, and that's going to be congruent to 1 because 2 to the 6th is actually 64, congruent to 1 mod 7. 64 is divisible by 7 9 times with a remainder of 1, so that gives us this being congruent to 1 mod 7. So what we're able to do is take anything of this nature. If we have 2 to the 35 power, we're able to rewrite the 35 as equal to 6 times 5 plus 5. So what that means is that this 2 can be written as 2 to the 6th power raised to the 5th times 2 to the 5th power. And what's this is going to do is this is going to be congruent to this right here is going to be 1 times 2 to the 5th power, and that's going to be congruent to 32, which is congruent to 4 mod 7. So that's what we're having happen here for this. You can also take a look, even if this was a larger number, 2 to the 75th power, we'd want to break up 75 into its portions of 6. So we'd have 6 times 12 plus 3. And so we could rewrite this as 2 to the 6th power raised to the 12th. And this is going to give us our 1 times our 2 to the 3rd power. And so what this is going to be congruent to is 1 to the 12th and 2 to the 3rd, which is then congruent to 8, which is then congruent to 1 mod 7. So this is how we're using Fermat's little theorem when we have our numbers given to us.